Dear students, my name is Sir Kumel, and today the topic of my lecture is current divider rule. In current divider rule, I will teach you how to calculate the current flowing into a resistance. First, I will draw the circuit for current divider rule. I will take two resistances, R1 and R2. R1 and R2, and I will connect these two resistances in parallel combination with each other. To connect in parallel combination, always connect the first terminals and the second terminals with each other. Now take an independent current source and connect this independent current source in parallel combination with these two resistances. You all know that in parallel combination voltage is always same across all the elements. So here the voltage is plus minus V. This voltage is same across R1. This voltage is same across R2. If I say the voltage across R1 is V1 and voltage across R2 is V2, so V1 will be equal to V2 and these will be equal to V, because in parallel combination voltage is always same across all the elements. In parallel combination the current is divided. That's why the name of the topic is current divider rule. So current is actually dividing here. If I say the current which is flowing from this independent current source is IT, means total current. This total current is actually divided among two currents. The first one is I1, which is flowing through R1, and the second current is I2, which is flowing through R2. Sum of these both currents will be equal to total current IT. So I1 plus I2 is equal to IT. Now you can take any combination from these two combinations. Here you can take V1 is equal to V or V2 is equal to V, because I have to find out the formula. I have to drive the formula for the current flowing through a resistance. If I take V1 is equal to V, you all know from Ohm's law, V is equal to IR. So here V1 will be I1R, I1R1, and V will be ITR equivalent. What is R equivalent? R equivalent basically is an equivalent resistance of all the resistances connected in parallel combination. In previous lectures, I have already taught you series and parallel combination of resistances. In series combination, I taught you the equivalent resistance is just the sum of all the resistances connected in series, and in parallel combination, the equivalent resistance is the sum of reciprocal of all the resistances connected in parallel. So here two resistances R1 and R2 are connected in parallel. So 1 upon R equivalent will be equal to 1 upon R1 plus 1 upon R2. You will just take the LCM of R1 and R2, and then you will reciprocal on both sides. First take the LCM and then reciprocal on both sides. So equivalent resistance will be R1 R2 upon R1 plus R2. In parallel combination, equivalent resistance is equal to R1 R2 upon R1 plus R2. Put this formula of equivalent resistance here. So I1 R1 will be equal to IT multiplied by R1 R2 upon R1 plus R2. R1 will be cancelled by R1. So I1 will be equal to R2 upon R1 plus R2 multiplied by total current. So this is the formula. This is the formula for I1, the current flowing through R1. I1 is the current flowing through R1. So I1 is equal to R2 upon R1 plus R2 multiplied by total current. Now, what is the conclusion of this formula? Listen carefully. The conclusion is when in current divider rule, when two resistances are connected in parallel and an independent current source is also connected in parallel with these two resistances, we have to find the current flowing through each resistance. Here I have derived the formula for the current flowing through R1, which is I1. Now you can see the formula. In numerator, R2 is here, and in denominator, the sum of both resistances is here. In previous video lecture, the topic was voltage divider rule, and the formula which I have derived, you just saw the voltage across the resistance is equal to the resistance itself in the numerator, the sum of both the resistances in denominator multiplied by total voltage. But here in current divider rule, the resistance other than R1, which is R2, is here in numerator. We are calculating I1, but in numerator the resistance is R2, which is other than R1. Sum of both resistances in denominator and multiply by total current. So understanding this conclusion, you can easily write the formula for I2. I2 will be equal to R1 in the numerator, sum of both resistances in the denominator, multiply by total current. This is the formula for I2, which is the current flowing through R2. R1 in the numerator divided by sum of both the resistances in denominator, multiply by total current. So here is the end of this lecture. Thank you very much.